So this video is still on the chapter of square matrices. We have been introducing the concept of complex matrices. I'm going to introduce now some properties of complex matrices. So I just remind you that A bar means the conjugate of a matrix A. Okay, if A is a matrix, right, its conjugate is A bar. So some properties are: the conjugate of A plus B is A conjugate plus B conjugate. The conjugate of K, where K is a scalar and A is a matrix under complex entries, the conjugate of those is the conjugate of the complex times the conjugate of the matrix. The conjugate of the conjugate is the conjugate. For the conjugate of A times B is the same as conjugate of A times conjugate of B, and the transpose of A conjugate is the conjugate of A transpose. Okay, I'm going to prove some of this. Let me see where I start. Well, I'm going to do like a normal person, and I'm going to begin with the first one. Okay, very first one. Proof. So we want to prove that the conjugate of A plus B is the same as conjugate of A plus conjugate of B. Okay, so we're going to write A as Aij, right, as usually. B we write as Bij, and now we have addition here. Okay, so let us say A plus B conjugate. I have to call something else here. I'm going to call it Cij. Okay, let us see what this Cij is. So this Cij is the same as Aij plus Bij, those two, conjugate, right? But this is the same as Aij conjugate plus Bij conjugate, right? Okay, and this is nothing but A conjugate plus B conjugate, right? So that concludes the proof. A plus B conjugate is the same as A conjugate plus B conjugate. So now I'm going to prove second property. The conjugate of Ka is equal to K conjugate A conjugate. Okay, proof. So we pick Ka. Ka will be Aij, the matrix Aij, multiplied by a given K. Okay, so what is Ka conjugate? Since Ka is this, Ka conjugate will be Kij conjugate, right? And this is nothing but K conjugate Aij conjugate, right? And since this is a product, we can do K conjugate times Aij conjugate, right? And this is nothing but K conjugate times the matrix A conjugate. You can check the entries are all the same. Okay, so K times A conjugate is the same as K conjugate A conjugate, and that concludes the proof. Okay, let us take the third one. So the third property says the conjugate of the conjugate is the matrix. Okay, so this one is really easy. First we are going to call the conjugate Cij, right? Okay, but let us see what is Cij. Cij is nothing but Aij conjugate, right? Okay, but now we conjugate the entries here. So the conjugate of the conjugate is A itself, so this will be Aij on every single entry here. We cannot say that about matrices, we can say that about entries. Now we said that about every single entry, so we can say that about Aij. Okay, but what is Aij? Aij is nothing but A. So the conjugate of the conjugate is the matrix itself, and that concludes the proof.